Jiangling, have you ever played Xbox?
Of course.
Which one?
Golf, table tennis. What about you?
Me? Well, actually, I played Dance Central too. And then after that, I never went to the dancing club anymore.
Oh, I
It was
understood.
a lot of fun.
I see. Yeah, thanks for Microsoft. That Xbox actually brought to us totally changed our way of living in the living room, in the entertainment space.
Yeah, so today we are honored to invite someone from Microsoft to talk about Xbox Kinect. Mr. Raj Master is the GM for IC packaging, silicon operations, quality and reliability for all hardware products in Microsoft, including Xbox, accessories, Zune, keyboard, mice, and webcam. Before that, Raj was a corporate fellow and chief technologist for AMD from 1996 to 2008. He joined AMD after spending 21 years at IBM as senior technical staff member. Raj has 47 US patents and has published over 70 technical papers.
Raj will present Design for the Future.
Now let's welcome.
Okay. The Chincha left, but I'm glad to hear that PC is not dead because Microsoft thinks the same way. Last year, believe it or not, we have this question all the time. Apple is going to kill Microsoft and so on. And last year, his number was slightly off. We actually sold 260 million software licenses. So PC is not dead. And it depends on what you want to do. It'll probably never be dead because things you can do with PC to create things, you sometimes can do with tablet. The other thing I want to dispel the myth is I'm not going to talk about software. And I also want to tell you that Microsoft is not just a software company anymore. It's actually a hardware company. And when I moved to Microsoft from AMD, all my friends from IBM and AMD said, what the hell are you doing at Microsoft? You know nothing about software, you couldn't do DOS, you can't do anything. You couldn't save your life if you needed to doing anything with software. So hopefully after we get done here, you realize that Microsoft does a lot of software and has done it for a long time. And this particular picture is our campus in Redmond. Futuristic campus, pretty nice. We have cafeteria and a massage parlor and manicure, and you can get your computer fixed and also have to work sometimes. Very nice campus, probably taken on one of the 28 non-rainy days in Seattle. I don't live there, but it's not usually like that. So Microsoft hardware has been around for 30 years. It started with keyboard and mice and cameras. There are a number of different groups that do this. In 1982, it started with PC hardware. And then it evolved into Microsoft mouse, webcam, conferencing, and ergonomic keyboard came into place a little later. 1999, optical mouse, and then Xbox series started. Is there another not well-known hardware called Surface? How many of you know what Surface is? Anybody? Very few. How many of you watch stock market or NFL, ESPN, or Weather Channel? You guys see those guys go like this, touch stuff? That's all Surface. Unfortunately, Microsoft didn't do a good job of commercializing. If you go to AT&T store, they have Surface. And now, a consumer-friendly Surface is out in the market. Still not very popular, but it's an example, original example, how natural user interface started. And then followed by Xbox 360, the Kinect, and various mouses that we make. So there are actually 4 major hardware groups. I'm just going to talk about hardware today. People who make specialty devices like Surface, mice, keyboard, and so on. And then interactive entertainment business, which makes Xbox, Kinect, accessories, and of course there is a part of interactive entertainment, as you can imagine, makes games, studio. Whole group of people who make mobile communication hardware, or we make other people enable the hardware by designing the right software, designing platforms. We know we have Windows Phone now and so on. And to do all that, there is a whole organization that I belong to. It's called Manufacturing Supply Chain, which has sourcing, quality, reliability, and so on. The interesting story, when 2001, when Xbox was launched, I think we had just come out and Sony had come out, and Microsoft decided we should do something. So they decided, let's build Xbox. Anybody want to imagine the size of hardware team? I'll give you guesses. Anybody want to imagine? How much? 500. Any other guess? 200. Okay, 10 people. 10 guys got together and said, we have lots of money, let's build Xbox. And that's how the whole thing started. They had no clue. And even today, some people have no clue. You still hear people in software side of the world. Oh, you have a hardware problem. Why don't you put a patch on it? Tomorrow you can have a fix. It's hard to convince them. If you screwed up, you have to wait till the next time to design it. So it's gone through the evolution. And there are, I would say today, right now, more than 1,000 hardware engineers working on all this stuff. Compared to where we started, which was 8 or 10, with all kinds of talent. They had no sourcing, they had no quality, they had no nothing at the time. So talk about Xbox for a second. A lot of people also think, don't know. They made the Xbox for fun. I don't know how long Microsoft is going to be doing business and so on and so forth. Those of you know it's now 10 years and counting. It's a long-term commitment. As you know, you read press, that it is the choice gaming console today in the world. Over 66 million have sold, and if you read press, the other console guys are going down, and Xbox is going up because we are bigger games, Connect, and so on. And there are nearly 40 million live subscribers. So Xbox Live is those of you know Xbox Live. Anybody know Xbox Live here? Use it? You can play with your friend in India or China or Russia or wherever using Xbox Live. The other interesting thing that Xbox Live does for us is it has a telemetry built into it. So we can actually identify whose console it is, but there's all kinds of data that is fed into every time you turn it on, turn it off. You play a game, how hard does it get, how long do you play, how many times did you turn it on and off? So you get all the telemetry data. And why is it all important? Because it allows us to understand how users use the console. When you start designing, you're just guessing. And one of the reasons Apple has been so successful is because they've been able to predict users. And I kind of claim that nobody knows how users will use something, and we'll talk about some examples. So the telemetry tells us how to design better consoles. And then it's become entertainment hub. It's no longer playing games. People watch Netflix, people watch HBO, people go shopping. Actually, the example you showed from Cisco is also one of the Connect applications. People compare clothes, compare with your girlfriend, you're planning for a wedding, look at wedding dresses and so on. Video on demand. And one of the most popular is avatars. If you have a Windows phone and if you happen to be in Microsoft, you'll see that they have a little application on my phone. I don't know if you'll see it. There's a little application. Instead of phone numbers, there are people's pictures in it. And half those pictures are avatars. People are identifying my admin's picture is an avatar. And everybody identifies themselves with an avatar. I guess they're alter ego in some way. And then we introduced Connect. And I have to tell you the truth. We introduced Connect in 2010. I knew for sure I was going to get fired as soon as it was introduced because there were so many unknowns. And many of them related to not the design of the system, but how users might use it. How many times will somebody grab Connect and tilt it manually? No idea. Or how many times will the thing go up and down? There were people who thought, oh, you have two kids, one kid will throw the connect to the other kid in the bed, in the living room, and what if it falls down and breaks, and so on and so on. So I thought I was going to get fired. We kind of thought maybe we'll sell a couple of million. Well, in the first 60 days, Connect actually broke world's record. We sold 8 million that we didn't think we could make, and we made them and sold them. And it's just the beginning. As you'll see, a lot of different experiences are going on with Connect. And leads to transformation. I'm sure Ashita has not thought about all the possible uses the human brain will use, all the interfaces it's going to create in the future. So there is no way to predict. Brain is still smarter than everybody else. And what's happening is the whole industry is getting transformed. The ecosystem has changed. You want to be connected on everything. On your phone, on your car. In my particular phone, although I don't like it, when I pair it with Bluetooth, somebody sends me a message, they reads the message and asks me, do I want to respond or not? Do I want to ignore? GPS. And all the devices we are sensing it by either GPS, accelerometers, some kind of sensory touch. And all that data is exploding. And 10 years ago, or 12 years ago, when I left IBM, I thought cloud computing was complete nonsense. I wouldn't go to any conference. I thought it was one of these, flash in the pan kind of thing. Good for creating 10 conferences a day, make some money, but I've learned that I was wrong. Cloud computing is the only way we're going to be able to manage all this data in real time. I have so many pictures. I'm sure some of you use Flickr or you send it or one of those things. SkyDrive, Microsoft uses. Great. All cloud computing. You get the data when you need it. This particular presentation is fairly large. I think it's 60 megabytes or something. I never have a hard copy of it. Just download it from the cloud. So, with the data explosion, cloud computing is becoming super important. And as you know, social computing is driving. I don't learn anything but my son from him. Actually, I learned from his Facebook page. And my relatives from India said, hey, did you know he has a girlfriend? Like, really? He hasn't told me about it yet. Oh, did you read his Facebook? No, I don't go to Facebook. The other thing that's happened with all this is, I'll tell him, saying, why don't you call home? I have no time. Really? No time to call home? No time. I'm so busy, I'm working, I'm doing this. And now look at his Facebook page, which is updating like every microsecond. I went here, I went there, but all that is consuming data. And all this is, this is all cloud computing. And everybody's connected. So natural user interfaces, he talked about displays. Who had thought about displays that people will do multi-touch and there'll be brightness and there'll be so many pixels and resolutions, and I'm sick and tired of my computer telling me my display is not optimized for what PC is doing. Like, it should happen automatically. Why do I have to worry about it? And those are the kind of things that he was mentioning. I'm not talking about software, by the way. I'm a hardware person. I know nothing about software, I hate them. Natural user interfaces are becoming more and more important because, when I got to Connect, again, the same guys on Facebook, of course, I gave him Xbox and Connect. He never connected it. I'm so busy updating my Facebook, I never have time to play with it. One day he calls me and says, Dad, this is fantastic. I never knew anything like this. You could do this, I could play golf, I can do Dance Central, I can talk to my friends, I can do, why did it take you a year to do it? But he's now hooked on it. And the only reason he's hooked on it because you plug it in, you start using it. How many of you read instruction manuals? Nobody. If you really look at it, Apple doesn't even have an instruction manual. Because, famous saying, I'm all you say, the only time you read an instruction manual because after you tried everything else and it doesn't work, you read the manual. So, things are becoming intuitive. People want to plug and play. They don't want to mess with it. That's why I hate my stereo system. Every time something goes wrong, I have to call somebody to fix it because everything is connected with cables and wires and nobody can figure out what it is. Would it be nice if everything was connected by Bluetooth and you don't have to worry about it? But it's not there yet. So natural user interfaces are becoming, fact of life. And how we are going to use them in future, I think sky is the limit. And some of the things we never imagined that we were going to do, we are doing them. And I kind of look at it like this. I came from technology world, and every time you hear, oh my God, transistor is at the end of limit, cannot ever make it. Nobody will be able to make a fuel efficient car. Making natural user interface, just 20,000 leagues under the sea kind of book. I don't know if some of you know Eric Von Daniken, but he wrote a book long time ago about spaceports and Star Wars. If you read this book, he described Star Wars in his book maybe 50, 60 years ago. And everybody used to think he's a crazy guy. And it goes on like that. So people will overcome challenges. One of the powers of human brains is they're proved over and over and over again. Give them a challenge and they will overcome it at some point. There's no such thing as you can't overcome it. We've gone from transistor you hold in your hand to molecular transistors. And a few years ago, if somebody told somebody molecular transistor, they'd just laugh at you. So, give you an example of how transformation happens. This little invention, it's 60 years ago. If you guys recognize these three guys, Bardeen, Shockley, and Bratton invented transistor, and you had to hold it in a hand. It was so big. And this is where we are today. 45 nanometer transistor, you need a SEM to take a picture of it to actually see anything. Anybody else know what Bardeen is more famous for than transistor? Huh? Supercomputer. Something related to that. Anybody know? No. He's the only guy who has won Nobel Prize in the same discipline twice in physics. So pretty famous for that. So today you can fit hundreds of transistors, size of single blood cell. Or you can fit more than 2,000 45 nanometer transistor on width of a human hair. Or more than 2 million transistors on the end of the sentence. There is a period that you can't say. You can put 2 million transistors. And 1948 to now is not a relatively long time, 50 years. If we asked them then, they would have never thought. But as we have challenges, people transfer, people evolve. So it's a continuous process. Same thing here, density and performance is going up. 45 nanometer transistor turns on and off 300 billion times a second. And this is the one of my guys gave me. Beam of light travels less than 1/10 of an inch during the time it takes 45 nanometer device to turn on and off. Pretty amazing. And like the previous speaker talked about, we are going to be far ahead of this. Where will we is just limited by imagination and not accept the fact that there is limitation of any kind. Because once you do that, game is over. Those are the naysayers. Never happen, never happen. So let me talk about semiconductor. I'll talk about console design using CPU and GPU on an SoC. I can talk about it now. I used to be AMD. I was never allowed in this building before. So in 2010, Microsoft actually, company that you automatically assume I talk about software, came up with an SoC which had an integrated CPU, GPU, and NOR bridge. And as you can see, things have migrated. 45 nanometer transistor is 372 million on each die. The current generation of Xbox, we have sold roughly 30 million consoles. 30 million processor in those consoles equals 4,800 trillion transistors, if you can imagine. And each of them have to work, by the way. It's not like we have half of them, if they don't work, things will go fine. So that's the scale of things that have happened. And in order to do this kind of thing, there's a large hardware team, silicon team at Microsoft. And every time I go hardware recruiting, Same question, well, what is Microsoft doing in hardware? So, if you hear Steve Ballmer, recently, last year or so, he calls Microsoft a device company now. He doesn't call himself Microsoft as a software company. And just want to give you an idea where Microsoft is compared to industry. So I've listed the nodes on the top and the three major semiconductor players and where they are. And you look at Microsoft, and most people are surprised that we are pretty much at the leading edge of the industry. And why are we there? Because in order to design Connect, or in order to design a console, with GPU, CPU, SoC, and so on, we have to take advantage of the leading edge features. That is what's allowed us to lower the power, make it nice, thick looking console because we can simplify the motherboard. Everybody wants everything smaller. Manage thermals. That's a whole other topic, how thermal is going crazy in the world. And that's another barrier that people have to overcome. So in order to do that, we have to take advantage of leading edge both graphics as well as processors. And if you think about Connect and console together, there are more than 140 silicon-based components in it. Some are jelly bean, some are not so jelly bean, and things that always fail are the jelly bean because everybody pays attention to the great stuff. And since I'm part of reliability, I always worry about that. It's something that I assume to be on the shelf, buy it, will fail. So, those of you guys are in silicon world, I assume semiconductor world should feel happy it has job security forever because as we do more and more complex stuff, we need more and more silicon, less and less power, faster and faster, and smaller, and so on and so on. And when you think about this, what are the challenges that faces silicon world? And I do a thing with my team on scale and complexity. They all feel very happy. Oh, look what I built. I built Connect, I did Xbox. And I asked them, what if you had to do 10 products like that? How are you going to scale up? If Microsoft is so seriously committed to hardware, they're going to do various products in the future, you need to scale. And same goes for silicon. So we shrink everything, we make everything thinner, and we want the higher reliability. And they're kind of like, don't go hand in hand. So one of the things that has happened is you need to understand users, because if you don't understand the users, you don't know how they're going to use the product, and you're going to design the wrong thing. Or you're going to design a tank that you don't need. Because I don't know how many of you, but most people change their PC within the first 3 years. My PC died in 2 years, 11 months. It was designed exactly right. When I was at IBM, philosophy, nothing can ever fail. It has to last forever. IBM server would last after you're dead 10 times over. Why? And you pay so much money for it. Which no longer is the case. Yes, it was a great thing in space and great thing for military, but no longer a great thing for consumer. And same with material challenges. Lot of material challenges. Dream come true. Materials guys' dream come true to work in this new kind of field. I'm just talking about semiconductor here, but the material challenges in my mind are one of the most enormous challenges facing the future, because we're trying to do things that sometimes don't obey laws of physics. And we are increasing the product complexity. You want to put more stuff in. You want everything in the phone. I never want to use I've heard many other devices. I don't want to carry anything but my phone. I want to do everything. I want to do PowerPoint on it. I never want to carry 3 devices. That day will come, sooner or later. I'd like to show you a short video on Connect.
We started with a sensor that turned voice and movement into magic.
Xbox, play.
We thought this would be fun to play with, and it was. But something amazing is happening. The world is starting to imagine things we hadn't even thought of. Unexpected things. Helpful things. beautiful things. Inspired things. Which is why, even though the world keeps asking us what we'll do with Connect next, we're just as excited to ask the world the same thing.
So, I have to take a minute here and say that, nobody imagined the way these things are used. We had a call recently, some surgeon wants to use Connect in the surgical, with a Microsoft stand behind it. We said, absolutely not. We never tested it, we don't know how it works, you might screw up somebody's brain, There are people who are using it. I read a recent thing in the paper that somebody wanted to connect to their phone, go to grocery shopping and have Connect with all the barcodes, and at the end of it, you know exactly what your bill is. And if you take it some way further, why do you need checkout counters? You should be able to transmit the data directly to the checkout counter, and you never have to check out because you pay what you're supposed to pay, and you can do it on your phone. So all kinds of applications that people are not imagining that are going to happen. So in order to deliver this kind of thing, you need flexibility, meaning, greatest thing that you design, like you said, if you can't make it, doesn't do any good. My favorite thing for system architects is you can design anything on CAD, you can't really make it sometimes. So you have to be flexible. You have to be able to change with the problem set. You need to have discipline. So that's the big difference between something in R&D. PrimeSense had this technology for a long time, but they really didn't know how to commercialize. And then you need to have relentless focus on doing stuff. Because as we know, consumer electronics changes very fast. We just complain about Microsoft hardware, we don't do things fast enough. And that's because we need to learn how to do things fast enough. So, in order to do that, you need to design for excellence because, as you know, if you drop your phone in water, you still expect to work it. You shouldn't really expect it to work when you do. So people have all kinds of expectations, which you can't judge. In order to do that, this is not a new thing. BFX, which is designed for whatever, designed for assembly, designed for compliance, designed for reliability, so on and so on. It's a systematic methodology that one needs to apply when you design the product so that you can achieve the end result you need. So if you take this is the interesting thing I was talking about, user environment. Nobody at Microsoft or anywhere else had thought about some baby using their controller to play Xbox. We had not thought about user experience, we didn't know how to test it. How do you go test for a baby? How are they going to play? Just imagine if that thing got hot, that might be too good. So people of all ages enjoy this and they will use it like you have no idea how they're going to use it. And it's a big challenge for anybody who's in this field. And I already talked about, we're just scratching the surface. Some examples here, I don't know if you can read, is Lakeside Center of Autism is using Connect to work with children with autism so they can see stuff. Rehabilitation program in England to rehabilitate people with stroke so they can see what's happening. And there are all kinds of experiences that people will develop on their own that Microsoft UX guys can't even imagine because, a lot of people have very powerful brains with lots of neurons, they imagine all kinds of stuff they can do. So, in case of Connect, I'll give you some examples. Design for assembly, you have to be able to do this quickly. We have to make hundreds of these things an hour. It's not like I'll make one and I'll declare victory at some conference and life goes on. It gets hot. And if it gets hot and we put a fan on it, it makes a lot of noise, people don't like it. You'll be amazed. One of the challenges with Xbox was acoustics. We had some spec, 45 decibel, and we were at 46 decibel, and everybody threw a fit. didn't understand why, but you'll be surprised. You take it home, your son will say, your box is too loud, Dad. It's 1 decibel difference, but people hear it. Sensory perception is an amazing thing. Okay. So there are all kinds of things that you need to do for assembly that you can assemble quickly. And a lot of these things are manual. You have to go through the whole exercise of that discipline. Same with testing. So one of the big challenges for Connect was you had to develop new optical calibration and test methodologies. How do you simulate if you're in your house, you're facing east, you have a glass window, and the sunshine is shining right on the Connect, blinding the sensor, versus somebody's in Tokyo, he's in a small room, and standing right up front of Connect, it should still work. Or if you're in Atherton and you're in your 100-foot long living room playing Connect, it should work there also and can't have any errors. So it's a big challenge. How do you do it? Each of the systems gets tested in the factory for calibration. I don't know if it's fun job or not. I wouldn't like it, but there are people who work in factory all day. They're jumping around and dancing, trying to calibrate this thing. And I kind of say Dance Central is great, but this is getting ridiculous. So you have to also design something that you can make. So you have to do design for manufacturing kind of approach in terms of discipline. So in future, natural user interface, how we will do things, how people will use anything is just limitless. So in order to do all this stuff, I've just kind of listed all the skill sets that one might need. And if you look through this, is probably every discipline that you can imagine, and all of these people have to work together. That's one of the big things about Connect and design for integration. I don't know about other companies, but I know in my past at IBM and AMD, and I'm sure at Intel, there's silicon silo, and there's back-end silo, and there is in-between silo, and software don't talk to anybody, and nothing ever works when it comes together. Or, typical, I designed the silicon, it's got 5 billion transistors, can't you just make it work? Like, did you not think about, no, I can't make it work because I can't package it, I can't test it, I can't ship it, so on and so on. And so, when you think about it, all these different skill sets are required to make these products in an integrated fashion. I cannot emphasize, Achintya also did the same thing, system integration. The greatest Nobel Prize winning person is not going to design new Connect. It's just not possible. I had the pleasure working from Stanford one time. You might not be there. Paul Flory, I don't know if he's still there. He was Nobel Prize in chemistry. I was at IBM. I was a young engineer. He came in, and I was like scared. Like, I'm going to talk to this guy. He's going to think I'm so stupid. And I described what I was doing, and he said, "Are you really expecting me to solve your problem?" I didn't know how to answer that, yes or no. They were going to be offensive, right? So I didn't say anything. He said, "Hey, I have no clue what you're doing, and I'm not going to solve your problem. All I can tell you is if your thinking is correct or not." And so we need people who understand this, how to integrate it, and how to work together without having large egos. So, and this is my funny cartoon here. You see a phone, and you see next to this all these gadgets, camera, blah, blah, blah. They were all in the phone. And the world is becoming, like you see the guy on the right, looks like not materialistic, but God has a cell phone. So, world is going mobile in many different ways, not just phone. And, we're packing more and more stuff. And you have to believe, if you had showed this picture to someone 10 years ago, they would say, "I don't believe it. Impossible." There's another picture. I have some African women in middle of Africa on some riverbank talking on phone. There's nothing around it, but they have their cell phone. And can you even imagine your life without cell phone? How many people still use fax machine? Nobody. So you have to believe that new things are going to happen. We will overcome all the boundaries that we don't think are possible today. Nobody thought we could go to Mars. Many of the things we do today are just unimaginable. So you have to believe that we have to innovate. People will come up with new products, and life is going to get more and more productive. And someday computers are actually going to tell you what the brain is thinking, possibly. Don't know, but it's possible. So with that, I want to thank you for giving me the opportunity to talk to you. I hope I convinced you that Microsoft actually knows something about hardware. And, thank you very much.